Hey everybody, how's it going? So as usual, I'm going to continue my essential LeetCode questions from Brian created list. So today I'm gonna work on a new section called metrics. And let's start with the first question. So set metrics to 0. So the goal of today's question is not just solve the problem, but I want to optimize the memory usage. So usually metrics traverse requires of nm, where n is the number of row and n is the number of column. So the optimum runtime is most of the time of mn. So my focus for today, this video, is to optimize the memory usage, meaning how to minimize usage of space complexity. So I'm gonna divide into 3 steps. First step is to solve the problem with the worst memory usage. Second step is a little bit of optimization, and third step is try to do the best solution. So that's my goal for this video. I have spent an hour to solve this question, and I want to leave this video also for myself to remember my approaches to the problem. So let's do it anyway. So goal setting, as usual, is, so let's read the question. We're given a matrix m and n. Element is 0. If an element is 0, and the entire row and column should be updated as 0. So in this example, if the center is 0, and then 0, 0 strikes out for the second row and the second column. This example is the same. So 0 is on the left corner. So the first row and then first column, as well as the last column, should be 0. Okay, so update the metrics. Also, the question defines we need to do it in place. So update the metrics in place. What about the constraints? You should have constraint 1, 2, 3. Okay. So the length of row, length of column is both more than 0. So no empty metrics. And maybe 0 is not always guaranteed. Element 0 is not guaranteed. Okay, so that makes sense. And we can have duplicates. But it really doesn't matter. But it doesn't matter in this case. So what's my approach? So obviously runtime should be of mn, but my focus is the space complexity. So first I'm gonna aim not too bad solution of mn space complexity. What I'm going to do is create a copy metrics. If copy metrics of row and column is 0, then update the metrics. Does that make sense? yeah, so we don't want to update yeah, so the reason why we create copy metrics is that after we, if we only try to update these metrics itself, for example, if we in the fifth traverse we found 0, and then we update 0, 0, 0 for the second column, and then we still continue the traverse, and then when we encounter the next 0, but this is we shouldn't strike out the last row based on the ace element, because this 0 is the updated 0. It's not the original 0. So maybe we should add as constraint 4 is that updated 0 should not strike out the entire row column. So updated 0 and the original 0 is different. That's the rule. So that's the idea 1. So I'm gonna implement this anyway. So let's create lengths. So the capital R is the length of matrix, which means length of row, and then capital column is the length of column. So length of column is matrix of 0. The reason why I specify 0 is that it can be 0 or 1 or 2, but we don't know how many R exist. Yeah, so but then according to the constraint, we are guaranteed to have 0, at least 0 row. So I'm gonna specify 0 in the matrix. So now we have length of row, length of column. Let's do it. So for row in range of R, capital R, and for column in range of capital C, and then we can traverse. But what first we need to create a copy matrix. After we create a copy matrix, we do something. So if copy of row or column is 0, and we update matrix of row column 0, so that's the rule. So how do we create a copy? And so okay, so maybe first we can create copy of 1 times number of column, which is C. Actually, let's say copy is C, copy is array. And then before that, I'm gonna create copy. Okay, so I'm gonna create copy. We can create a number of column times number of row. So anyway, I first declared copy matrix, and then we want to update copy of row column. So row column is the matrix I'm gonna create. I'm gonna copy from matrix. So that's the row column, and then let's debug. If you have copy matrix. So if you have 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, yeah, we should be able to see that. So copy of row column is matrix row column. Ooh. Okay. Okay, so I just want to create a copy right now. So I was wrong. Let me just do this way. So I'm gonna create copy row first. So, and it can be any number. So I'm gonna start with 1, and then yeah, so 4. So I'm gonna do 4 nothing in range of column. Create a temp row, and then do the for nothing in range of row, and let's print to make sure we have copy. Yeah, so we start with the copy. We start with the dummy copy matrix, and then after that we update, we actually create a copy. Okay, so it seems working. So we have done the initial setting, and then finally, so that's step 1. Step 1, and then step 2 is to update metrics. Okay, so finally we can do that. So if copy matrix is 0, and then we update the matrix to 0. Oh, actually, we need to strike out. Okay, so not just update the matrix, not just update the matrix, but we want to insert 0 row, 0 column. Okay, to do that, we need to create a 0 row. So 0 row is just a 0 times number of column. So we're gonna do something like matrix. So matrix of row. So we can say matrix of row equals 0 row. Yeah, so now we have 0 row for the second row, and then we also want to update the second. We want to update the column as well. So if the copy is 0, we want to update to the column. So anyway, let's just finish the worst case approach. So I'm gonna finish this by just updating. So for row in range, we need to update. So matrix for R in range, for R of this defined column, we need to update at 0. So I know this is super slow, and this is not. So this is all M. This is all M squared, and And the memory usage is of mn because we create a copy matrix, but this is not the best solution. So what I'm going to do now is, let's just forget the idea one because this is too slow. So I'm going to comment out this. And then now we want to optimize as idea two. So idea two, it's a better resource usage, which is still the same runtime, but we can use all m plus n. So we're gonna create a row. So 0 row and 0 column, which is they are index of 0. So if the matrix of row and column is 0, then we're gonna append to the 0. And then 0 column, we're gonna append so that we know which column and row has a 0. So that's the first pass. And in the second pass, so if r in 0 row, c in 0 column, then matrix is gonna be 0. So that's the logic. Yeah. So to do that, we need to create r and c as lengths, and then 0 row, 0 column is the set. Is the set to store the index. So the first pass is the scan. So we're gonna scan to check which column and row has the 0. Okay. So matrix row column, if matrix of row and column is 0, and then we're gonna store into, actually not the append, but it's the add because we're using the set. So we're going to add. Why do we use set? Because the set, hash map is of constant access compared to array. In case of array, we need to traverse of n, so it's slow. That's why we use Python set operator. So that's that. So what we are done with the scan, and then we're going to update in the second pass. Update metrics. So this time, if row is in the 0 row, we're going to update metrics row. Column is 0. So this doesn't have to be row, but also equal to column, or column in the 0 column. Okay, so sorry, I had a typo. 0 row and column. Yeah, so now let me submit. So it is slightly better runtime and it is very good usage of memory, but this is still all n plus n resource utilization. So what I'm going to do is we're going to create, let's do the last operation. I mean, last approach, which is the best approach, optimal solution. What we're going to do is that, so idea 3, best space complexity. We're going to do 3 things. So first pass is the scan. How do we update? How do we know current metrics and row is contains 0? So we're gonna do the 2 things. If row and column is matrix of row and column is 0, then we're going to do what we're going to do is that so matrix of, we just remember only the column, only the top column, and only the first row as 0. So we're going to do matrix of 0 of the current column should be 0, and matrix of row and the first column is 0. So that's the scan. Now in the second scan, second pass, so if row, so in the second scan for row and column, if the matrix, so we're going to check if the parent of the matrix is 0, that means, you know, we have the flag, we know this is 0. Then we should update matrix of row and column, it should be 0. So that's so row and column is 0. So that's the second pass. Now, because we update the first column and first column and first row, we need to update the first column and first row at the end, because if we update first column and first row in the first pass, then it is confused, right? Whether we cannot differentiate if the 0 is the original 0 or updated 0. So the third pass, finally we need to update first row, first column to avoid the confusion. So let's do it. But as a setup, we need to know, check whether, first we should check whether first row and first column contains 0. So if so, update first column, first row, first column in the end. So what I mean is that, so we need to create 2 booleans, which is constant space complexity. That's why this idea 3 is the first better solution. So 0 first row and 0 first column, we are going to declare as false and false. These are boolean. That's the setup. What I mean is that, so we're going to do, so we're going to do 2 things. For row in range, we're only going to check metrics of the first column. So we don't care about column. So we define 0. So if any row of the first column contains 0, 0, and then we update 0 first column is true. Similarly, and then we can break. So similarly, if the matrix of 0 row, but the column contains 0, then we update 0 first row equals true, and then break. Yeah, so that's the setup. Now we do the first pass scan. Let's just copy. So if matrix of row and column is 0, and then we do the frag, and then in the second pass, we need to do the second pass. Oh, okay. Don't forget traverse. Don't forget traverse. So for row and column, update the matrix. Again, in the second pass, for row and column, if the matrix of the frag is 0, and update the matrix. And then at the end, we're going to update first row, first column. So what we're going to do is that if the frag is 0, so we need to check for both row and column is true, then we're going to update. So if the first row is 0, contains 0, then we need to traverse the column. We need to traverse the column and update the matrix. So 0 row and column should be 0. Similarly, for first column, we're going to traverse each row in R, and then update the row as 0. So that's that. So let's try to submit. Okay, so we're doing something. Okay, so we in the second pass, we only need to update. You know, from the range of 1 to R, because we're not gonna update except first row, first column. So don't update until third column for the first column of first length. So now it's accepted. So I'm gonna submit, and then yes, this is. So the statistic says memory usage is decreased, but so I don't know the reason, but in theory, what we have declared, it's the only constant memory. So R is the constant, C is the constant, 0 first row, 0 first column is the Boolean. So all of them are constant memory usage, which is pretty good. And we don't declare any other new variables. So this is the best memory usage solution. Runtime is the same, all of MN. We do this third, first pass, second pass, third pass, but all of them are all of MN. So in theory, this is all MN runtime and all constant memory usage, which is the best solution. This is a little bit tricky, but it definitely is a good practice to deepen our understanding about how we can optimize the memory usage. So thank you for watching.